In this video, we're going to sketch polynomials just using intercepts and turning points. So as it says here, showing the x-axis intercept, y-axis intercept, and turning points is enough to get a good idea of what the graph of the function will look like. Essentially, if I know that there's x-axis intercepts here, a y-axis intercept here, and a maximum turning point here, I can play dot to dot and get a good idea of what the function looks like. So let's look first at quadratic functions. We're going to look at quadratic functions, cubics, and quartics. In a quadratic function, if this a value, so the number beside the x squared, is positive, it'll be a happy face quadratic. There we can imagine there's happy faces there, or a negative quadratic, so the a is, say, -5, we'll have a sad face quadratic. Okay, so something to keep in mind. So we'll have a go at sketching x squared minus x minus 2, showing all intercepts and turning points. I'll start by identifying that the a value is 1, so a is greater than 0, so it's a positive quadratic. It's going to look something like that. From here, we're going to find all the intercepts and turning points. So I need to find any x-axis intercepts and also any y-axis intercepts. How are we going to find those intercepts, you may ask? Well, I know that if I have a point on the x-axis, I know its coordinates are going to be something 0. Okay, whichever of these points, they'll all have that coordinate something 0. So I know the x-axis intercepts are going to occur at y equals 0. And by the same reasoning, y-axis intercepts, if I have a point on the y-axis, its coordinates will be 0 something. So I know that these ones will occur at x equals 0. This should be revision. So now that I've stated those two facts, I can substitute y equals 0 into here to find my x-axis intercepts. So 0 equals x squared minus x minus 2. And I can substitute x equals 0 into that same equation to find my y-axis intercept. Substituting in 0 instead of x. So I'm going to let you have a go at finding the x-axis and y-axis intercepts, and we'll check on each other in about half a second. Hopefully that didn't take you too long. Notice that I have 2 x-axis intercepts and I only have 1 y-axis intercept. Okay. Typically you'll have multiple x-axis intercepts, but only ever 1 y-axis intercept. So I found my intercepts. Those are 3 pieces of information that are going to go on the graph. So I can tick that off, showing all intercepts. I also need to find the turning points. Finding turning points. I'll put a little heading so I don't get lost. Okay, I know that these occur when dy dx, when the slope of the function is 0. So I'm going to find these turning points and I'm going to classify them. You've done this a lot in the previous unit. I'll let you have a go at it again. I'll give you about half a second to try that. Okay, so you've had your half a second to do that, and hopefully by now you've found that a half and minus 2.25 are the coordinates of the minimum. So if I zoom back and take a look at what's going on and get my highlighter out, because I know you guys love using highlighters. I've got this piece of information, x-axis intercepts, I've got y-axis intercept, and I've got a minimum. I'm going to put correction, and I also know it's a positive quadratic. So I'm just going to use this highlighted information to sketch the graph. So I'll draw a nice set of axes and put these bits of information on. So now that I've marked all these points, I can do a fair bit of double checking. I also know that it's going to be a smiley face quadratic, so I'll just visually inspect this thing and make sure that I'll be able to draw it knowing that this is a minimum. If I classified this as a maximum, I'd think, all right, something's gone wrong. There's no way that I'm going to be able to get through that sort of a maximum and go through the other points. So I'll just play a bit of advanced dot to dot. Arrows on the end and label the curve. Okay, and I'll just probably show that this is a half and minus 2.25 if it's not clear from reading it on the graph. Okay, so what I've done is I've sketched the equation y equals x squared minus x minus 2, and I've shown all axial intercepts. So I've shown my x-axis, my y-axis intercept, and I've shown the turning points. Any questions? If you want to practice this type of problem, go there and do that. Now we'll move on to cubics. The cubics are exactly the same idea as quadratics. Okay, this a value is going to determine whether it's a positive or negative cubic. So these first two are both positive cubics, where the a value would be positive, and this last one, the negative cubic, the a value is negative. So I've got this cubic function. It's written as 3 factors, so this will help us out a bit. And we're going to sketch it showing all intercepts and turning points. So I'll go ahead and find the x-axis and y-axis intercepts. So having it factorized is actually going to help us out, because when I'm finding the y-axis intercept, it just generates my 3 solutions for me. Either this is 0, that's 0, or the other is 0. So here are my 3 x-axis intercepts. And makes it a bit easier for the y's as well. So the y-axis intercept, minus 1 times 2 times 4, to give me something like minus 8. So I can write the coordinates of all these axis intercepts. So now that I've found those intercepts, it's time to find the turning points. Okay, and I know that they occur when y dash equals 0. So I need to find what y dash is. I can write the function out again, and then go ahead and expand. So make sure each of these get multiplied by that final factor. So now that we've got our function in a nicer form, okay, we can go ahead and find y dash and set it equal to 0 and classify the turning point like normal. We can also note that the number in front here is a 1, so I know it's going to be a positive cubic, which is going to start from down here and do something like that in the extremes. I could have found this just by looking also at the numbers of x here. X times x times x would give me x cubed. Okay, which also indicates a positive cubic. Okay, so go ahead and find and classify the turning points. I'll give you half a second to do that. So I went ahead and found them and classified them. I couldn't factorize that quadratic, so I had to go to equation mode on my calculator. Okay, and I end up with a maximum, and I should have a minimum as one of these. Oops. Okay, 1 minimum and 1 maximum. I use the second derivative test. You can use whatever you want to classify it. So again, like in the previous example, obviously it's getting bigger, a little bit more complex because there's more information here. I have 3 axis intercepts. I've got my y-axis intercept, a 4th one. I know it's a positive cubic, and I've got those 2 turning points. So I'm going to draw the graph and put all this information on there. So I've placed all this info on my graph. If you struggle to draw the zebra in dot to dots, you're really going to struggle here now. When I put these turning points on, I think it's a good idea, if it's a minimum, to show it like that, and if it's maximum, to show it like that, just so that when we're graphing it, we know which way to go around those points. So this is my maximum here, so I'll just draw some little legs below it, and here I'll draw some little legs above it. Remember, I've got a positive cubic, So to the extreme left, it's got to come from down here somewhere, and to the extreme right, it's going to end up there somewhere. So with all that information in mind, I should be able to play my really sophisticated game of dot to dot, and I'll be able to go through these guys, through my minimum, through my turning point, through my y-axis intercept, and through my final x-axis intercept. Make sure I label my graph. And there we go. How can I verify this is correct? Put it in my graphics calculator. You might think, oh, this is huge, there's no way I'm going to be able to do this. Okay? All you need to remember is looking for x-axis intercept, y-axis intercept, and turning points. That's all it is. Find those things, you can draw the graph. Okay, to practice some cubics, there's a whole heap of practice ones in 3C for you to practice that skill. Okay, and now on to quartics. Okay, quadratic functions, as they say, ain't nothing changed but the game. Quadratic means the biggest power we have is the power 4. Okay, this is a positive quadratic, so is this, so is this, but this one is not, this is a negative. See all the positive ones, they extreme values are positive, they're going up to positive values, whereas the negative one is going down, a negative. Obviously, dependent on the a value, these have positive a values, whereas this guy has a negative a value. Okay, you're given a function to sketch to show all intercepts and turning points. It tells us what it's like expanded as well, so we don't spend forever going expanding brackets, because it'd take ages and you'd probably make a whole heap of errors, like I've been making errors in some expansions myself. Okay, so let's go ahead. Intercept should be the easy part. Let's find the x and y axis intercepts. I'll give you about a third of a second to do that. Well done, you found the intercepts. Okay, and now it's time to find the turning points. Okay, I'll give you a little bit of a head start. Okay, the turning points occur at y' equals 0. I'm going to use the expanded form. Okay, so y equals x to the power 4. Use that form because I'll actually be able to differentiate this, which is important. Okay, differentiating, should be able to do it this quick by now if you've been keeping up, which I hope you all have. And now I'll set y' equals 0. The reason why I'm going through this one is to let you know that at no time in this course will you be expected to solve a cubic function like that. Okay, that's graphics calculator territory. Okay, and when we're trying to solve things that have powers bigger than 2, go into equation mode. It's a polynomial, but the degree is 3, so I'll be able to type in the coefficients, and it should give me my x values. There they are. Okay, so find the y values for them and classify. Off you go. Make sure you enter in the coefficients correctly into your calculator as well. So hopefully you did okay with that, finding the turning points and classifying them. So I've got a minimum, a maximum, another minimum, and then I look up at my intercepts. I've got 4 x-axis intercepts and a y-axis intercept. Okay, and the only other piece of information that I haven't mentioned is when I look at the x to the power 4 term, it's got an a value of 1, so it's also going to be a positive quadratic. Okay, so I'm going to start and finish in the positive values. So let's put all this info onto a set of axes, and play the biggest game of dot to dot we've ever played in our lives. Yeah, again, lots of dot to dot going on, but I'm okay by that. It's positive quartic, so it's got to start up here somewhere and finish up here somewhere. So I'll play the dot to dot. Okay, better come down through that x-axis intercept all the way down to my turning point, and I'll turn around, come back up through this x-axis intercept, do a maximum on there, and then just zoom in on that. Yep, cool, maximum, and then y-axis intercept. Hopefully no one's getting seasick doing this problem. Through another x-axis intercept. 1.57 is a minimum. Okay, so it's looking good. Going through, and then up. Okay, like always, finish the problem by making sure you write the equation on top of it. For your CNJ. Okay, that's what that quartic looks like. Okay, you probably would have thought I'm never going to be able to draw this, but here you go. There's only one final little topic to touch on, which is over the page. If I was to have a look at this graph, if I was to find the x-axis intercepts the standard way, okay, I would note that they occur when y equals 0. Okay, and I'd think, well, what am I going to do with these squareds and thirds? So I'd think, well, I could just write them beside each other, get rid of the squared and write how many times this occurs. And then I could find all of my x-axis intercepts. Okay, so I get x minus 1 is 0, x minus 2 is 0, x minus 2 is 0 again. Okay, so this one's occurring twice. Call it a double. Okay, and I'll get x equals minus 1. I'll get it 3 times. Okay, so the idea is single, double, and triple roots. It's referring to how many times that solution or that intercept occurs. So the idea with a single root is that if that's the x-axis intercept, when it passes through, it'll pass through pretty much just through a straight line. However, if I have a double root, it'll pass, just touch the x-axis like a quadratic, like a parabola. If I have a triple root, it's going to pass through here like a cubic function would. And we can see that on our graph where my single root at x equals 1, okay, it just passed through like normal. My double root at x equals 2, here it is, just touching like a quadratic. And my triple root at x equals minus 1, we see it coming through like a cubic. Okay, so with this knowledge, hopefully we'll be able to sketch this function. Okay, we'll just focus on the x-axis intercepts. If we wanted to, we could find and classify the turning points as well. Okay, so I'll just find the x-axis intercepts. So set y equals 0 and see what happens. So even when you just look at this function, you should be able to tell that there's going to be a double root here. Okay, because I've got x minus 1 repeating itself. Okay, so we'll find what all of these intercepts are. So I end up finding a double root at 1, 0 and single roots at minus 2, 0 and 3, 0. If I'm trying to find what sort of a quartic this is going to be, I can just look at the x values. So I've got x squared times x times minus x, which if I multiply all these together, we get minus x to the power 4. Okay, so I know it's going to be a negative quartic. Okay, just looking at the x values. So from here, I'll draw up my axes. I can mark these points on, so I'll put my double root at 1 and single roots at -2 and 3. I know this is a negative quadratic correction, negative quartic, so it's coming from down here somewhere. It's going to end up down here. So when I pass through this line, it'll be relatively flat. Okay, and I know when I'm coming down to this 1, it's going to be looking like a quadratic there, because at 1 it's a double root over here. So just an alternative way of going about drawing these. And now it's got to come up, go through that double root, just touching the y-axis, another maximum. Okay, and here it goes, something like this. Okay, so the purpose of this last sheet is just to get you used to the idea of single, double, and triple roots, that they exist. Obviously, if I was doing this problem in an exam, I'd also find coordinates of these turning points and the y-axis intercept. Okay, but this is just to demo the idea of single, double, and triple roots. So, quick recap: what have we done? We've looked at sketching quadratics, looked at sketching cubics, and we've looked at sketching quartic functions, just using the intercepts and the turning points. So there's a few questions to have a go at for you to practice. Should give you plenty of joy and excitement. All right, thanks.